Okay, so what we have here is a diagram with several different things happening. I have some lines that are marked parallel, and I have a whole bunch of angles that are created. So basically what we're asked to do here is to find the measure of all these different angles that are marked. Now, in order for us to do that, we have to remember what we've learned so far about parallel lines and the angles that are formed, and about the triangle angle, interior angle sum theorem. So I'm just going to uh, mark my diagram so that I can look at it a little more clearly. I'm noticing that lines P and Q are parallel. So I'm going to mark those with one color. And then I'll mark the transversal. And actually, there are two transversals here that are intersecting these parallel lines. So I'll mark the transversals with another color then, with the red. That'll help me identify some angles. So when you have a diagram like this, where we have those parallel lines cut by transversal, or transversals in this case, thinking about things like alternate interior angles being congruent, corresponding angles being congruent, alternate exterior angles being congruent, same side interior angles being supplementary, and same side exterior angles being supplementary. Also remember that the triangle, I'm noticing a triangle here, that measures the angles in a triangle, the interior angles of a triangle, sum 180 degrees. So I'm keeping all those things in mind. So when we have a diagram where we have got all these different things going on, really you want to start focusing your attention where some angles have been filled in. So my eye is immediately drawn here because I see the couple angles filled in. So what we can either do is take a look at the linear pairs and figure out the corresponding angles, the angles that form that linear pair, or we can take a look at this triangle. It doesn't really matter, but we'll start somewhere around where we have angle measures filled in. So I'm going to start with the triangle, and I know that the interior angles of a triangle add up to 180 degrees. So I'm going to add 49 and 82 degrees, which gives me 131 degrees. And I'm going to subtract that from 180, which will give me the measure of angle G, and I can see that that's 49 degrees. So whenever you find something, my advice when you have a picture like this where there's lots of different angles is to fill in the ones that you find. Then later we'll identify them where we're asked to. So now I have that. Now I'm going to go to the angle B, which is the supplement to 49, because the angle that's at 49, that measures 49 degrees, and angle B are a linear pair. So I'm going to subtract 180 minus 49. We did 180 minus 131 to get 49, so 180 minus 49 is going to be 131. So that angle B is 131. Okay. Next, so if I know that angle, I can take a look at where the transversal intersects the parallel lines, and I can see that the angle that is 131 degrees, angle B, is corresponding to this angle here. So I'm going to go ahead and fill in 131 there, because when parallel lines, which we have here, are cut by a transversal, then corresponding angles are congruent. So if that's 131 degrees, then A forms a linear pair with 131, which means that angle A measures 49 degrees. Okay. Now, I'm also looking out for vertical angles as well. I know that vertical angles are congruent. So that means this one here is 49 degrees. That means this one here is 131 degrees. I'm just filling in anything I know. It might be helpful, it might not, to find the ones that I'm looking for, but I'll fill in all the ones that I know. Also vertical to angle B, that's 131 degrees, and this one would be 49 degrees. Okay, so now let's take a look to see what else we can fill in. Well, we can fill in the linear pair, the supplement to angle, the one that's marked 82 degrees. So 180 minus 180 degrees minus 82 degrees will give me the measure of angle F. So if I subtract 82 from 180, I get 98 degrees. So F measures 98 degrees. So now I can see the blue parallel lines cut by this red transversal here. Again, we have corresponding angles congruent, alternate interior angles congruent, alternate exterior angles congruent, same side interior angles supplementary. All those things can be helpful here. So C and F are same side interior angles. They're on the inside of the parallel and the same side of the transversal. So they're going to be supplementary. So if I have 98 for F, I can subtract 180 minus 98 to get the measure of angle C. Well, I already did 180 minus 82 to get 98, which means 180 minus 98 is going to be 82. So C is 82 degrees. I could have also gotten C using corresponding angles. It's a corresponding angle with the one we already had marked as 82. So now I can go ahead and fill in vertical angles. And I can go ahead and get the supplement of 82, which is 98. We already figured that out. And again, over here, the supplement is 98. So we have that filled in. Looks like the only other thing we haven't filled in yet would be angle H, and I can see that's a vertical angle with angle G, so I know that the measure of that angle is 49 degrees. Now that we've put the puzzle together, I like to think of it like a little puzzle. We put all the pieces together, now we can identify the measure of each angle. So A is 49 degrees, the measure of angle A. The measure of angle B, that's 131 degrees. The measure of angle C is 82 degrees. The measure of angle D, that's 98 degrees. The measure of angle E, E is 98. The measure of angle F, that's here, that's 98. The measure of angle G, that's right here, 49 degrees. And the measure of angle H, that's here, 49 degrees. Okay, so that's how we would approach a problem that has lots of different angles going on, just thinking about all the things we know about parallel lines cut by a transversal, and also triangle interior angle sum theorem, and also vertical angles, and also linear pairs or supplementary.